Hello and welcome back to my channel. Today we are going to discuss the last two questions, that is 11th and 12th from the specimen paper for the examination from 2020, and it is pure mathematics 1, that is 970901. So here's the question number 11. The function f is defined for x to real number, so it is defined for all real numbers by f from x to x square plus ax plus b, where a and b are constants. It is given that a is equal to 6 and b is equal to minus 8. Find the range of f. Since it is defined for all the real numbers and we have this value, I'll write f of x as x square plus 6x minus 8, and this graph will look like this. Now we can find the minimum value here, and we can say this fx would be greater than this minimum value, and we will get it from here by using the completing square method, and it is x plus half of 6 is 3 whole square minus 3 square is 9 minus 8. So it become x plus 3 whole square minus 17. So here we can see the minimum point. From here the minimum point is going to be minus 3 comma minus 17. So the range of f is going to be fx greater than or is equal to minus 17, because it would always be positive whatever value we put, all the real numbers, and since it is going to be greater than or is equal to 0, so fx will always be greater than minus 17. I hope it is clear. Let's do the b part of this question. Here's the b part. It is given that a is equal to 5. Now earlier it was b also provided, now they have only provided a is equal to 5, and that the roots of equation fx is equal to 0 are k and minus 2k, where k is a constant. Find the values of b and k. So from the factor theorem we know if these two are roots, if k and k minus 2k are roots, it means x minus k and x minus 2k are going to be our factors of fx, and here fx was x square plus ax plus b, and the coefficient of x square is 1, and if we multiply these two we will get again coefficient of x square. So we can say that this fx is going to be x minus k and x plus 2k, the factorized form. Now we will compare, and a is given 5, so we got it as x square plus 5x plus b is equal to x minus k into x plus 2k, or we will expand this and we will get it as x square minus k plus 2k is plus k x and minus 2k square. So if we'll compare this and this, we'll get k value as 5, coefficient of x, so k is equal to 5, and when we'll compare the constant terms we'll get b is equal to minus 2k square, or b is equal to minus 2 into 5 square. 5 square is 25, so 25 into 2 is 50, and hence b is equal to minus 50. That's the values of b and k. Let's discuss the next question. Here's the c part of this question. Show that if the equation f of x plus a has no real roots, then a square is less than 4 times b minus a. So we have f of x as, it is x square plus ax plus b. So if the input was x, this function is x square plus a times input plus b. So if I change the input by x plus a, this will be input whole square, that is a x plus a whole square plus a times input, that is x plus a, plus b, means we just substitute the value of x as x plus a. Now we have given that this has no real solution, it means we'll solve this. So according to this, f of x plus a is equal to a, means it is x plus a whole square plus a times x plus a plus b is equal to a, or we'll write the quadratic form. We'll expand it. It is x square plus 2ax plus a square, then this ax plus a into a square plus b minus a is equal to 0. One more time so that we can get ax square plus bx plus c form, and we will get it as x square 2ax plus ax is 3ax plus the constant terms a square 2a square plus b minus a is equal to 0. So if no solution, no real roots, it means discriminant d is going to be, which is b square minus 4ac, it should be less than 0. So we'll calculate from here, and b is 3a, so it is 3a square 9a square minus 4 times a is 1 and ac, c is 2a square plus b minus a is less than 0. And now we will simplify it a little bit more. 9a square minus 4 to the 8a square. Now I'm going to take this collectively so that I can get minus 4 times b minus a, because we can see there is a, in the question it is 4 times b minus a, and we are getting here, so it would be easier to solve. And 9a square minus 8a square is going to be a square, and I'll transfer this to other side, and we got the answer 4 times b minus a. That's it. Let's discuss the last question of this paper. Here is the question number 12. The diagram shows the curve with equation y is equal to x times x minus 2 whole square. The minimum point on the curve has coordinates a, 0. It means it touches the x coordinates, x-axis, sorry. And the x coordinate of the maximum point is b here, where a and b are constant. First one is state the value of a. So if this curve is touching the x-axis at a, so we can say at this a, 0, this y is going to be 0, means x times, that means a times a minus 2 whole square is 0, and since a cannot be 0 other than 0, so a should be, a minus 2 whole square should be 0, it means a minus 2 is 0, hence a value is 2. So we have one value of a, we have the value of a, that is 2. And here's the b part. Calculate the value of b. Since y has its maximum value at x is equal to b, so it means at b dy over dx would be 0. Differentiation means that the gradient of the tangent at this point would be parallel to x-axis, means it is 0, and hence we'll find dy over dx first. Dy over dx is, we are going to solve it by product rule. X a, this is first function, this is the second function. I'll write first function as it is, x, and differentiation of second function is 2 times x minus 2, and then second function as it is, that is x minus 2 whole square, and differentiation of second function, that is only 1, because differentiation of x is 1. So it is going to be, I'll take x minus 2 common, and we will left with 2x minus x minus 2. So it become x minus 2 and 3x minus 2, and since at b dy over dx is 0, and hence it is going to be x is equal to 2 or 2 by 3, but we know that at x is equal to 2 it is a, so b value is going to be 2 by 3. So these are the two roots, at 2 and at 2 by 3. So b value is 2 by 3. Let's discuss the C part. And here's the C part. Find the area of shaded region. And we know that this is origin and this is A is equal to 2. So area under the curve, area of the shaded region means area under the curve from 0 to 2. So area is going to be integration of y, and it is with respect to dx x from 0 to 2 is the area, means we will expand it 0 to 2, and x into x minus 2 whole square is x square minus 4x plus 4 dx, and it is 0 to 2 will simplify x cube minus 4x square plus 4x dx. So the integration is going to be x power 4 over 4 minus 4x cube over 3 plus 4x square over 2, and the limit 0 to 2. Now we'll simplify upper limit 2, and if you put the lower limit 0 everywhere, so it is 0. So upper limit 4 is upper limit of x is 2, so it is 2 raised to the power 4. 2 raised to the power 4, it is 16 over 4 minus 4 over 3 into 2 square is 2 cube, it is 8 plus 4 by 2 x square means 2 square is 4. So let's simplify. These two got cancelled. 4 4s are 4 2s are 8 plus 4 is 12 minus 32 over 3. So it is 12 3s are 36 minus 32 is 4 over 3. That's the area. This is square unit, 4 by 3. So that's it. Let's discuss the last part. And here's the last part of this question. The gradient dy over dx of the curve has minimum value m. Calculate the value of m. This question is of the type, if fx has, we need to find the minimum value of fx at some point, so we find derivative of fx. Here we have dy over dx as one function, so if we want to find its minimum value, then we have to differentiate this. So it is like ddx of this dy over dx, which we know is double derivative of y with respect to x, and dy over dx from the previous part we have seen it was x minus 2 into 3x minus 2, which is 3x square, and 3 2s are 6 minus 4 minus 2 is minus 8x and plus 4. So its double derivative would be 3 2s are 6x minus 8. So for the minimum value or maximum value, this has to be 0. So for minimum value, it is going to be x is equal to 8 over 6, that is 4 over 3. So we got value of x for which dy over dx is going to have its minimum value. Now what is that value? We will get it from here. So value of dy over dx, or I should write minimum value of dy over dx is at x is equal to 4 by 3, and hence this is going to be value 3 times 4 by 3 square minus 8 times x, that is 4 by 3 plus 4. So it is 3 into 16 over 9 minus 8 4s are 32 over 3 plus 4, and 3 cancelled. It is 16 over 3 minus 32 over 3, means it is minus 16 over 3 plus 4. 3 4s are 12 minus 16 is minus 4 over 3, and that's the minimum value of dy over dx. And since it is given the minimum value minimum value is m, so it means m value is minus 4 by 3. In these type of questions, we only need to have this clear idea that they are asking for the minimum value of dy over dx. So for minimum value of any function, first of all we find the derivative of it and equate it is equal to 0, so that we get the x values, some x values to at that point the function is going to have its minimum or maximum value. And since dy over dx, for dy over dx we are finding, and it has x square coefficient as 3, means the curve is going to be like this, so it will have a minimum value, and this minimum value is m. So we will differentiate this again, that is second derivative of it, and we will get the x value from there. And for this x value, this dy over dx is going to have its minimum value, and that minimum value is when we replace this value, substitute this value of x as 4 by 3, we will get that minimum value, and that is given as m. So that's it for this video. I hope it was of some help. So let's meet again in the next video with other past year paper solution. Till then, thank you so much.